4.7 is all about our inverse trig functions. So to start, at the top of your paper, go ahead and get a sketch of y equals sine of theta, y equals cosine theta, and y equals tangent theta, because we need to be able to look at those graphs in order to really talk about their inverse functions. Make sure for y equals sine theta, it should look about like this. Now my graph does go all the way up to 4 pi in this case, so you will have a little bit of it cut off. Like you probably stopped right around here for the 2 pi and the negative 2 pi, but that's fine. For y equals cosine theta, instead of starting at 0, right here where sine did, it should start up at the top. So it should be like that. And I went just a little bit past 2 pi with this one. Negative 2 pi, but still, your graph should look very similar to that one. And then for y equals tangent theta, you should be starting at 0 as well. And I just have my last part cut off here for that negative 2 pi, where it should be like this up curl. That's awful, but that graph like that. So you have a general idea of what your graphs look like. First question, do these graphs have an inverse? Which, if you recall, to have an inverse function, it has to pass the horizontal line test. So no, because really all of them, if I drew a horizontal line anywhere, I'm going to hit my graph multiple times. So that's not going to work. So that's just a no. What if you just look at a section of the graph? So let's focus in on our y equals sine theta, and we're actually going to focus on that interval from negative pi over 2 to positive pi over 2. So I'm focused in right here. This was my negative pi over 2. We're down here at negative 1. For positive pi over 2, it was up here at positive 1. Looking there, you have a few important things happening. So on this interval, that function is increasing. It covers all of your possible ranges for values of sine. So it goes all the way down to negative 1, all the way up to positive 1. And if I just look in that section, it passes my horizontal line test. So that section, I have an inverse. So on that restricted domain, if you will, so between negative pi over 2 and positive pi over 2, there is an inverse sine function. We call it either arc sine, or like you've seen before, that sine inverse. These mean the same thing. Whenever in your calculator you have typed in inverse sine, if I'm thinking about this in degrees, just to help give me a clear picture of what I'm looking at, because a lot of times we prefer degrees. If you've ever typed in your inverse sine, it only gives you answers between negative 90 and positive 90. So whenever you're doing your inverse sine or arc sine, it should be between there. Now, you might be able to then extend that to a different quadrant using your reference angles. But my actual answer for arc sine or inverse sine should be between negative pi over 2 and positive pi over 2. And I do want you keeping these in radians. I put the degrees there just as a comparison for you. So let's do a couple of examples. And when you're thinking about these, remember arc sine or inverse sine is the angle whose sine equals this. So I want to know the angle where the sine is negative 1/2. So if I'm on my unit circle, we've already said we have to be between that negative pi over 2 and that positive pi over 2. So I have to be over in this area somewhere. Sine being a negative 1/2, so that's my y, negative 1/2 should be that first dot right there. So it's an awful circle. But that first dot in that quadrant 4, which if you remember on your unit circle, if you're looking straight at your unit circle, is 11 pi over 6. Since I do want my answers to be between that negative pi over 2 and that positive pi over 2, that means to get there, that negative angle would be a negative pi over 6. Try the other two. Sine inverse of radical 3 over 2, so I'm looking at my unit circle. I can't be on this side, I'm just going to be on the right side. Radical 3 over 2 positive would be up here. And that's almost to 1, so it should be that top dot, which is that pi over 3. And that does fall between that negative pi over 2 and positive pi over 2. So my answer is pi over 3. Over here, sine inverse of 2. So where does sine equal 2? It's not anywhere on my unit circle that I can think of. So if I do sine inverse on my calculator, I'm getting an error. Oh yeah. Sine can only be between -1 and 1. So I can't have used any angle and ever gotten an answer of 2. So you can't do sine inverse of anything that's more than 1 or less than -2. This is simply going to be undefined. Alright, so we do also have these same things happening for our other trig functions, looking at cosine and tangent. So let's start off with when we're looking at y equals arc sine of theta. That only works if sine of y equals x. So basically, my y here is my angle. I want to say this angle is my arc sine. So that means that I did sine of that angle and got that value of x. My domain for that is -1 to 1. So the only numbers that can be plugged into my x had to be between -1 and 1. My answers should all be between negative pi over 2 and positive pi over 2. I have an illustration to help with this. So let's think of our unit circle. This is negative pi over 2. This is 0. Pi over 2 and pi. And instead of using this one as 3 pi over 2 to 2 pi, because that would be very awkward to say it can be between 3 pi over 2 and 2 pi, or 0 and pi over 2, so that this is a continuous side is why we say negative pi over 2. So sine can happen on that right side between negative pi over 2 and positive pi over 2. If you recall, part of the reason we liked this was we got our full range of -1 to 1 for our sine values. Since cosine correlates to that x, to get the full range of -1 to 1 for our arc cosine, our domain is actually still -1 to 1, but our range rather is going to go from 0 to pi. So I can still only get the same answers of -1 or 1 to go into my arc cosine. But when I do that, I should be between 0 and pi when I actually perform my inverse cosine or arc cosine. So sine is over here on the right, cosine is on the top. Tangent, if you think back to our original graph, when it was going up like this, it didn't have a maximum or minimum, rather. It just went everywhere, all the way up and down forever, whereas sine and cosine leveled off at that 1 and -1. So when we do arctangent, again, my angle is what my arctangent equals, so it's what I did tangent of. I can do arctangent of anything, since I could have done tangent and gotten any answer. It went all the way up to infinity and down to -infinity. My answers for arctangent, because I only wanted to get just this one cycle so that it passes that horizontal line test. If you're looking at your graph, to get that full cycle there is between -pi over 2 and positive pi over 2. So tangent is also on this side. So I have sine on the right side, cosine's on top, tangent is on the right side as well. So whenever you do inverse sine, your answer should be on this right side. Same with inverse tangent. If you're doing inverse or arc cosine, your answers should be coming from that top part. Let's try a few more. So arc cosine of radical 2 over 2. So I'm looking at my unit circle. For cosine, I know I have to be on top, so I don't really care about this part down here. And I know cosine correlates to my x value. So where my x was radical 2 over 2 would happen right there at pi over 4. Because over here, it would have been a negative. So my answer is just pi over 4. Try arc cosine of -1. So it's asking what's the x value, or what's the angle that gives you an x value of -1. My x value of -1 would be over here. That was at pi, which is between 0 and pi, so that works. Arctangent of 0. Looking at my unit circle, I'm only on the right side. So I want to know what's the angle that gives me a tangent of 0. Remember, tangent was y over x, so I basically want my y to be 0. Over here, the only place that happens is right here at 0. And if you want to check these, you could always type in your calculator tangent of 0. In this case, the answer should be 0. Over here, if I wanted to check it, I would do cosine of pi. My answer should be that -1. So that's kind of how I'm checking it. Try the arctangent of -1. Okay, you should be on the right side. If I'm dividing y over x and getting just -1, that means that my y and my x are the same, but one of them has to be negative while the other one's positive. Over here, the only place that happens is down in quadrant 4 at what would be 7 pi over 4. But remember, you're thinking of it as that negative angle for these, so that's negative pi over 4. And again, you could always check it by doing tangent of negative pi over 4 in your calculator or on your unit circle if you need to, and you should get -1 as your answer. For these, you're doing them on your calculator. If you recall, when we did our table, everything was between negative pi over 2 and pi over 2, or 0 and pi, all in radians. So make sure your calculator is in radian mode. And I'm going to just do second, tangent, and then I'm going to type in my number, -8.45. Second tangent gives me that tangent inverse, or that arc sine. So when I type that one in, I get -1.453. Go ahead and try the other ones. When I did arc sine of 0.2447 or inverse sine of 0.2447, I got 0.247. Oops. Over here, when I did arc cosine or inverse cosine of 2, I got error, and that makes sense because remember, you can't take your inverse sine or your inverse cosine of anything that's more than 1 or less than -1. So that one's just undefined. Compositions of functions. Basically, if I'm doing sine of arc sine of x, the sine and the arc sine will cancel each other, and I'll just be left with the x. Going backwards, arc sine of sine is going to cancel each other, left with y. As long as whatever's inside your arc sine is between -1 and 1, and whatever's inside your sine, if you're doing this one, is between -pi over 2 and pi over 2. So let's do a couple examples of those. Tangent of arctangent of -5. So I'm looking here, that follows this one. X just has to be a real number. X is a real number, so those are just going to cancel. So this says tangent of my angle whose tangent gave me -5. Well, I already am defining that as tangent of that angle equaling -5. Here, arc sine of sine being 5 pi over 3, so you would want them to just cancel, but that's outside of that -pi over 2 to pi over 2 range. So all you have to do is think about where 5 pi over 3 would be. 1, 2, 3, 4, 5 pi over 3 would be right there. So if I was doing that as my negative angle to make it land between -pi over 2 and +pi over 2, that's -pi over 3. Cosine of my cosine inverse of pi, I cannot do arc cosine or cosine inverse of anything that's more than 1. 3.14 is more than 1. So that one, again, is undefined. Find the exact value. I think for these I'm actually going to run out of time to do this, so I'm going to pick up another video real quick. It's only probably about 2 minutes for you.